All right, let's talk about something that's probably running behind the scenes on a bunch of apps you use every single day. It's a database called MongoDB, and it was built specifically to handle the messy, unpredictable, and constantly changing data that modern applications thrive on. We're going to break down exactly how it pulls that off. So you might be asking, why did we even need a new kind of database in the first place? Well, just think for a second about a typical social media profile. You've got a name, an email, sure, but you've also got a list of friends, maybe some photos, comments nested inside of other comments. All of that data is connected, but it's not neat and tidy. And trying to cram that into the old-school, rigid tables of a traditional database, it's like trying to fit a square peg in a round hole. It just doesn't work well. And this is where MongoDB just completely changes the game. Instead of those rigid tables and rows, it uses these super flexible things called documents, and they are perfect for that kind of messy, unstructured data we were just talking about. But here's the real kicker. It's built to scale horizontally. Now, what that means is, instead of having to buy one giant, ridiculously expensive super server to handle more traffic, you can just add more normal, cheaper machines to your team. For modern web apps, that is a much, much smarter way to grow.
Okay, so to really get how this all fits together, we got to break it down to its most basic parts. We're going to start with the two fundamental building blocks that everything else in MongoDB is made of: documents and collections.
First up is the document. This is the absolute heart and soul of MongoDB. The best way to think about it is like a self-contained digital resume. It's written in a format that looks a lot like JSON, which is just a really simple way to organize data. It has fields like name and values like Alice. But here's the magic. One person's resume can be totally different from another's. Yours might have a list of skills, while mine has a link to a portfolio. That flexibility is just incredibly powerful. So if a document is a single resume, then a collection is basically the filing cabinet where you keep all those resumes. It's just a grouping of similar documents. But, and this is the important part, unlike a traditional database table, this filing cabinet doesn't force every single document inside to have the exact same structure. It's cool with the fact that one file looks a bit different from the next.
So with potentially millions of these documents, how on earth does the database keep track of every single one? With this little thing right here, the ID field. You can think of it as a unique, non-negotiable serial number for every piece of your data. Every document gets one. If you don't add one yourself, MongoDB just makes one for you. And this ID is absolutely critical for finding a specific document in a flash and for keeping all your data straight.
Okay, so we know what the pieces are. Now let's talk about what we can actually do with them. We're moving on to the core toolkit. This is the basic language you use to talk to the database, and it goes by the simple little acronym CRUD.
CRUD stands for the four most basic things you can possibly do with data: create it, read it, update it, and delete it. These are the action verbs of the database world, you know? You use insert to create a new user. You find to read their profile data. You update to change their password, and you delete to remove their account. Pretty much everything you'll ever do boils down to one of these four operations.
But, and this is a big but, when you go to update something, there is one rule you absolutely positively cannot forget. You have to use what's called an update operator, like $set, to tell MongoDB exactly which field you want to change. If you forget to do that, you're not just going to change one piece of information, you will accidentally replace the entire document, wiping out everything else. Trust me, it's a painful mistake most developers only make once. So, we can create data, we can manage it, but what happens when your app blows up and suddenly you have millions of users? How does MongoDB handle that kind of intense pressure? Let's zoom out and look at the big picture strategies for how it gets big.
And it really all boils down to three main ideas that work together beautifully. If you want to understand how it grows, just remember this simple framework: speed, safety, and scale.
First up, for speed, you have indexing. And honestly, an index works exactly like the index at the back of a textbook. Instead of the database having to flip through every single page, or in this case, every document, to find what it's looking for, which would be incredibly slow, it just looks at the index and jumps straight to the right spot. It is a massive, massive win for performance.
Next, for safety, there's replication. This is basically your data's insurance policy. You don't just have one server holding all your precious information. Instead, you have a whole group of them called a replica set that are constantly keeping synchronized copies. So if your main server ever goes down, one of the backup servers is automatically promoted to take its place. This is huge for preventing data loss and keeping your app online.
And finally, for true mind-boggling scale, we have sharding. When your dataset gets so big that it can't even fit on one really powerful server anymore, sharding lets you chop it up and spread it across a whole fleet of machines. Each machine, or shard, holds just one piece of the total data. This is how MongoDB can grow to handle practically limitless amounts of information.
So we've got the building blocks, we've got the language to talk to it, and we've got the strategies to make it huge. But maybe the single most important decision a developer makes happens way before all of that, right at the very beginning. Let's talk about how you model your data. When you're figuring out how to structure your data in MongoDB, almost everything boils down to this one central question. A question that's going to affect your app's performance, its scalability, pretty much everything. And that question is, do you embed your related data, or do you reference it?
Okay, so here's the core trade-off. You embed when you have a one-to-few relationship. Think about a blog post and its comments. There are only a handful of comments, and you almost always want to read them at the same time as the post. So you just nest them right inside the blog post document, super fast. But you reference for one-to-many relationships. Think about a product in an online store. That one product could be part of thousands of different customer orders. You do not want to copy and paste the product info thousands of times. So instead, you just store a reference or a link to the product.
So let's just bring this all home. When you put it all together, what does MongoDB really offer? Well, more than anything, it offers freedom. It's the flexibility to let your data model change and evolve as your application grows. It's the power to scale to massive sizes using smart tools like indexing, replication, and sharding. And honestly, it's just a more intuitive and natural way for developers to work with data.
And that kind of leaves us with one last thought to ponder. We've seen how MongoDB's whole flexible model was really designed to mirror our complex, fast-changing digital world. So the question is, if our data models are really just reflections of our world, what does a database that's built on flexibility and adaptability tell us about the future that we're all building together?